Example 2. Calculate the work required to stretch the following spring 0.4 meters from their equilibrium position. Assume Hooke's law is obeyed. From the given information, a spring that requires 2 joules of work to be stretched 0.1 meter from its equilibrium position. The goal is to calculate the work that required to stretch 0.4 meters from their equilibrium position. Based on the information provided, W equals 2, as work can be calculated by definite integral from equilibrium point. The problem said the work to be stretched 0.1 meters from its equilibrium position. Equilibrium position 0, stretched positive direction to 0.1 meter, multiplied by the F of the force. With respect to X, we do not know what is the K or the spring constant. We're going to find K. Since this situation obeys Hooke's law, so F equals K times X. Now the W will become like 2 equals the integral 0 to 0.1. F is K times X with respect to X. We do the antiderivative to find K. We get K times X to the second over 2, evaluate from 0 to 0.1. So 2 equals K over 2 multiplied by 0.1 squared minus 0 and solve for K. We will get K as 2 times 2, which is 4, divided by 0.01 or 400. Now we get K equals 400 as a spring constant. Therefore, the F would be K times X or 400 times X. And the problem asks you to find the work or W as the spring stretched from the equilibrium point 0.4 meters. So W is the integral from 0 to 0.4 of Kx, which is the force, with respect to X. That means we are going to find the antiderivative from 0 to 0.4 of 400 times X with respect to X, which is 200 X squared, evaluate from 0 to 0.4, which gives us 32 joules as the answer.